Okay, so for today's experiment, you need something like this, a frying pan. It doesn't have to be this big, and you need to fill it up with water. So I filled it up to about this much. I'm just thinking I'm going to fill it up a little bit more because yeah, the more you fill it up, I think it's going to be a bit easier. Okay, because what you're going to do is you're going to grab a can of Coke, empty can right now, and I want you to practice this movement before you start. So get some tongs, palm face up to the ceiling, and you're going to practice this movement of quickly inverting it into the water, like that. So practice that maybe 5 times before you do this experiment. So you've got to be able to do this nice and fast, so it goes plop into the water. Okay? You can press pause if you have to, whenever you want. Okay, so I've got my water. I've got my can. These medicine measuring cups are really good because they're 50 ml. And I want you to put 40 to 50 ml of water. So fill that up with about 40 to 50 ml of water into the empty Coke can. Okay? So the Coke can's got a little bit of water at the bottom, not much. Then you're going to get your tongs and we're going to go, if you've got a gas stove, like I do, you can warm it up on the gas stove. It's like the Bunsen burner, same type of gas. And we're going to warm it up until it starts boiling. If you've got an electric plate, a hot plate, it will work as well. So you can use an electric stove. Don't touch it. Don't touch it. It's going to be too hot. It might take a little while. So we want to boil it. So it's going to have water vapour coming out of it. We want it to be boiling quite vigorously. It's not there yet. The Bunsen burner does a much better job at this actually. I can hear it bubbling now, so that's a good sign. Now you want your water to be close to you. So if I were you guys, I'd have my pan over here and I'd do it like that. But because I'm recording, I want to get a good close-up, so I've got my pan far away. But that's only because I kind of know what I'm doing. For you guys, you should have your pan close to you. Have your palm turned upwards, so when you do your movement of putting it quickly into the water, when you do that, it's nice and close and you don't have to wait too long, because the trick is to do it quickly from the heat to the cold water very quickly. Okay, you can hear it boiling now. When I start seeing some steam coming out of it, that's when I'm going to do my upside down thingy. Okay. So how did our can crush work? Okay, so first of all we had our aluminium can. So remember it had a little bit of water in here. So when we heat the water particles, remember what happens when we heat something up to the particles? They start to, that's a flame underneath, that's heat. So when you heat particles, they start to vibrate more. And because of the vibrations, the intermolecular forces, or the bonds holding the particles together, start to break. So that means the particles can become further distanced apart. So they've got bigger distances between them. And remember, that affects the density. So the density decreases because there's less particles in the same volume. So here's our tub of water, which has lots of liquid particles, and the liquid particles are all closely packed together, not as tight as solids, but tighter than gases, right? Then we get our can of very heated up water, and so in the can the particles are spaced quite far apart because they were heated up, and all the water was escaping, all the water vapor was escaping out of the can because we got it boiling. So when we put our can slightly under the water, so we did put it a little bit under the water, the pressure outside, is a lot more than the pressure inside. And when I say pressure, another way to think about that, because we haven't really talked about pressure before, but I guess pressure is a type of density, okay? So the density of particles outside of the can was so much higher compared to the density of particles, my spelling's going all funny, the density of particles inside the can. So the can just imploded. It's kind of like stepping on the can. When you step on a can, you put a lot of pressure on it and it implodes. Same as when you get rid of all of the, or lots of the particles, and then quickly submerge it in water where there's high pressure or higher density compared to the inside of it.